rational exponents. So we want to see which of these don't belong. And so what we're going to notice here is just saying, hey, what's going on? So when I look at this, these two can't be the same because notice the numbers are in two different places. So this one is going to be equal to this one or this one, and we got to figure out which one. So we learned last time with the notes that anytime there's a fraction, the denominator is the root. So here, that denominator is going to be a 5, and that 4 stays as the top exponent. And so here we know this one can't be equal to. So this is not, so that, remember, the denominator is always the root, so those two can't be equal. Same idea here. This is either this or this, and so remember, this is a square root. Anytime I say this is a square root. So if I can do this, I can always draw a little 2 there. And so that's, if there's nothing there, it's a square root. So it's not usually there, so I know there's a hidden 2 there. And so I tell myself, all right, so the denominator is always the root. So since this is a square root, this is a 2 in the denominator. So that's why this one's crossed out. And those 2 remaining ones are equal. This right here, the whole goal of this is, oh my goodness, this is all ugly. So this is so ugly, so let's break it down. Here's my exponent. Here are my 2 roots. These 2 are exactly the same, except this has a negative, this doesn't. So when I look at this idea for a minute, I tell myself from last time, number one, we know that the denominator is the root, so that's not a problem here. But this negative, what the negative does, it has nothing to do with the sign of the number. It only deals with the what it looks like. So anytime there's a negative, it just becomes a fraction. So this one's going to be wrong because the negative has nothing to do with the sign. And so it has to be these 2 that are equal. So the negative in the exponent creates a fraction. And that's what the same exact thing here, right? This is a fraction. Therefore, it has to be a negative exponent. So that's why the middle one's crossed out. Right? And that's all it is on these, is just trying to get used to the ugly ones. So rewriting the following of radicals, right? So I'm going to radical, so I'm going to draw my 2 roots in. Except that's a little ugly. So I'm going to draw the 2 roots in. My base number is always inside. Remember, my denominator is always my root. And then the top just stays with the 17. Sometimes this can be written as this. Usually it's written as the top one. But every now and then some people will write it like this, and that's fine too. So both of those are the same. But usually people just keep it with the 17. Usually, I say that, but it doesn't really matter. All right. Now, I messed up a little bit here. I'm going to kind of squeeze it in. The negative makes it a fraction. So 1 over the square root of, or the root of, I should say at the beginning, 31 stays. The denominator of 2 goes on the outside, and then there's a 3 there. Or like we said, 1 over the square root of 31 all cubed. So either one of those are going to work. Sorry, I meant to put the 17 there. All right. So that's how you write a radical. All right. Okay. There's the answers. All right. All right. So, sorry. So there's the answers if you want to see it, how it looks like that. All right. This one's going to come across, same idea. I want to write this as an exponent. All right. So if I do this as an exponent, I'm going to start and say, okay, I know it's a 3. Since it's a root, I know it's a fraction. So the 4 is on the outside. Since it's a square root, I'm going to put a 2 here. And I know that 4 over 2 is 2, so this can just be simplified as 3 to the 2. And I can call that 9, but it says leave it as an exponent. Now, same idea in this one, right? It's a fraction and a root, so I'm going to start with the base, which is 5. I know it's a negative fraction now. The negative because it's a fraction, the fraction because it's a root. So I know it's going to be 6 over 3 because my root, the type of root is always my denominator. And then I know that can be simplified also, so that can be 5 to the negative 2, which I could simplify to 1 over 25, but this problem is, 1 over 25 or 25, but it says leave it as an exponent, so that's kind of what we're looking at here. All right, and that's it with these notes, just kind of getting an idea of making the really ugliness, say, hey, how do I get this ugliness to try to start making sense? All right, there you go.